Hello, good day. My name is Michael Whitaker. I am the manager of the International Safeguards Program at Oak Ridge National Laboratory. This session is going to be addressing in more detail IAEA safeguards implementation with an emphasis on specific inspection activities. The outline is to spend a little more time in this session talking about the IAEA as an international organization, focusing within the Department of Safeguards, who's responsible for implementing verification activities. Talk about some of the inspection activities that take place using an example facility of a fuel fabrication plant, and then summarizing where the agency is going in terms of its safeguards approach. It's important to start out that the IAEA is an independent, intergovernmental science and technology-based organization. It is one of the semi-autonomous organizations within the United Nations structure, so it is funded through the UN by contributions from all of its member states, but it does have the authority to act independently within this UN structure. Again, to emphasize, it is not directed solely by any one country or member state. The IAEA itself was created in 1957. This was a result, actually, of a speech 4 years before by U.S. President Dwight Eisenhower in front of the UN, his famous, for us in the non-proliferation field, Atoms for Peace speech. If you're not familiar with it, I encourage you to Google Eisenhower Atoms for Peace 1953 to bring it up, in which he laid the state of play within the global situation at that time and called for the creation of an International Atomic Energy Agency. So 4 years after that speech, the IAEA was indeed created in 1957. And it is composed of some policy-making organizations and a secretariat. The policy-making organizations, and I'll give a little more detail on each of these, are the General Conference, which are all the member states of the IAEA, which is now above 150 countries, and then a subset, which is a Board of Governors, which consists of 35 members. The Secretariat is the actual staff that implements and executes the IAEA's roles and responsibility. The current staff size is approximately 2,300 individuals, which is split roughly 50-50 between the professional staff and the other general services staff. The IAEA headquarters is located in Vienna, Austria. The country of Austria was very interested in hosting the organization. They built the entire building for the IAEA to use, and is basically rented to the agency for €1 a year. So it was a contribution by the Austrian government to want to host this organization, to play this, I guess, kind of a prestigious role in the international community. And that's how the decision for placing IAEA's headquarters in Vienna. The IAEA General Conference meets once a year in September, in which all the members come together and they consider the reports from the Board of Governors. I'll talk about them next. The board meets 4 times a year, and on this one General Conference, the members approve the accounts, the budget, and addresses any specific recommendations that come from the board. Other activities that take place is to approve any application for new membership to the IAEA, and it provides a forum for the debate, conversation, discussion among the IAEA members concerning the IAEA's policies and overall program implementation. The Board of Governors, as I said earlier, consists of 35 member countries, of which there are I believe it's now 15 permanent members of the board. These are the most advanced and complete fuel cycles. The other members, which I think is 20, will rotate. It's every 2 to 4 years. I think it's every 2 years, to include that the representation is diverse among regions in the country and its membership, so that all countries will have a chance to sit on the board, but the ones with the most advanced fuel cycles are permanent members. The board meets 4 times a year. It approves specific safeguards agreements between the agency and its member states. It approves publications of the agency key documents, such as its safety standards. It is responsible for actually appointing the Director General of the IAEA or submitting their recommendation to the General Conference for approval. The overall objective of the IAEA is, one, to seek to accelerate and enlarge the contribution of atomic energy to peace, health, and prosperity. In the nonproliferation field, we often tend to focus more on the safeguards and verification aspects of the IAEA, since that's generally what makes the news the most, or has kind of the higher impact. But the agency, again, dating back to its statute in 1957 and the call for its creation in 1953, is to further the peaceful applications of atomic energy. But their obligation or their role in the activity is to try to provide this independent assurance that atomic energy is not being used in such a way that can further any military purpose. To find more information about the IAEA and the IAEA statute, they have a very good and complete website at IAEA.org. If you've not visited that site, I strongly encourage you to do so to get the most current information. So, as I was introducing earlier, the safeguards and verification aspect is a very important aspect of the agency, but it's really just one of 3 pillars that make up the agency. The other being safety and security related to the handling, transportation, and possession of nuclear materials for either fuel cycles or other peaceful uses, and the overall science and technology. So more recently, within the last year or 2, you hear much more discussion of trying to integrate what is called upon as the 3 S's of safeguards, security, and safety, to make sure they all work together, that they can build upon each other, and definitely to avoid conflicts. So the way the IAEA enters into agreement with a country regarding specific safeguards activities in that country is in a formal, signed, comprehensive safeguards agreement that provides the responsibilities and the restrictions to both the IAEA and the member state. This is the basis for which the IAEA verifies that the declarations provided by a state are complete, such that they can then provide assurance to the rest of the world that there is no diversion of any declared materials taking place within that country. Also, these agreements are used by the agency to verify the completeness of the state's declaration. That is, that all nuclear material and all nuclear activities have been declared, such that assurance can be provided that there are no undeclared activities or materials present within the country. Let's talk a little bit about the secretariat structure. This is the organization that carries out all of the IAEA's programs and activities, and provides the information then to the policy-making organizations, that being the Board of Governors and the General Conference. The IAEA Director General is currently Mr. Amano from Japan. He became the Director General, I should know this, I guess 2 years ago. Since this is on videotape 2 years ago, may not mean anything to you, so that was 2010, I believe it is. The agency itself has 6 separate departments. Departments for nuclear sciences and applications, for general management, for nuclear energy, for technical cooperation, for nuclear safety and security, and then the Department of Safeguards, who we interact with the most. The current Deputy Director General for Safeguards is Herman Nackerts. Mentioned earlier, the staff of the IAEA is approximately 2,300 people, representing nearly 100 different countries to some degree. Again, as a UN organization, there is a strong desire and actually mandate to have diversity amongst its membership, which is basically supposed to be somewhat divided number-wise by the contribution from the various organizations. Just a point of interest, the United States is the largest contributor to the IAEA. We contribute approximately 25% of the IAEA's budget. In terms of staff size, the number of staff members are less than 20%. So we have less than our share of membership. And I think within the Department of Safeguards, the current share is something like about 14% of the employees. Looking at the staff within the Department of Safeguards in particular, remember this is one of the 6 departments. When the agency was created in 1957, there were 8 full-time members of the Safeguards Department. Over the next decade, it grew to 56. The next decade after that, it grew to 282. The agency in the mid-80s began a period of what is called near zero real growth. There was a slight increase to account for inflation, but there was not any increase in the budget above that. So the agency's activities were pretty flat between the mid-80s, 1985, and the end of the first decade this century, 2009 or so. Over the last couple of years, there has been an increase in budget. The staff of the Safeguards Group has, in that time, grown to 758, of which 2/3 are professional and the other third are general staff. So as opposed to the agency as a whole, where the professional and general administrative staff are 50-50, you can see that within the Safeguards and Verification Department, there is a slant more towards professionals. And as you can see, this 267 really represents about 1/4 of all the professional staff within the IAEA Secretariat. A couple of facts and figures as to the responsibilities of the agency. Looking back at their last complete Safeguards implementation report of 2009, you can see the breakdown of facilities and materials under Safeguards, where 232 power reactors, 156 research reactors and critical assemblies. You can see 46 fuel fab plants, 20 conversion plants, 16 enrichment plants, 13 reprocessing plants. There's 119 separate storage facilities and 445 lofts or locations outside of facilities. These generally have very small quantities of materials, which again may be universities or medical facilities that have small nuclear sources. In terms of number of inspections, looking at 2009 alone, inspections, there were 1,100 inspections conducted over the course of the year. Now, looking back, the professional staff is about 200, so on average, each professional staff does about 5 inspections a year. The number of facilities of LOF inspected is 600. The number of inspections over the course of the year was about 2,000. So you can see that each, well, I said the number wrong before. With 2,000, each person does about 10 inspections of 5 different potential facilities. The number of person days of inspections, which is the way the agency measures an inspection activity, was over 8,000. So you can see each of these inspections in general lasted an average of about 4 days. So on average, the professional staff spends about 40 days of inspection a year. For those that are your mainstream inspectors, they target about 90 days of inspection in the field. The last couple of years, I've been told it's actually been up to 110, 120 days a year. So the inspectors are basically on the road 1 out of 3 days a year. Let's talk about international safeguards. And here it's implied nuclear, but I think it's important to emphasize for this class. We're talking about safeguarding nuclear materials inside nuclear facilities. So if we don't put that nuclear in the rest of the talk, understand that that's put there. So by international safeguards, again, this is a system designed to provide assurance that nuclear materials and facilities are being used only for the peaceful purposes that they've declared to be. I want to emphasize again, safeguards are not to prevent activities from taking place. They are there to provide the assurance that they are taking place as declared. So there are 2 ways of looking at this. Just from the political perspective, a country signs an agreement with the agency that invites the agency to apply safeguards to its facilities. So that political aim is to make sure that the countries are complying with the terms of the safeguards agreement. Technically, when they apply safeguards to these facilities, it is, as we mentioned before, that they are having to make sure that the safeguard system can provide timely detection of the diversion of any declared nuclear material and has the ability to detect early any undeclared nuclear activities or the presence of nuclear material and to deter any diversion or undeclared activities by the risk of this early detection. Sometimes you'll hear people say the IAEA safeguards prevents diversion or prevents undeclared. It is not a preventive. All they can do is detect it after it happens, but the deterrence factor is the stronger word. It's not prevention, it's deterrence. So the general working hypothesis within the agency is that while these agreements are voluntary, the declarations come from the country, you assume that it's complete, you have faith in the other countries and their members and their activities. However, your working hypothesis has to be that non-compliance to these agreements cannot be excluded, that there might be a subset or the national authority itself has an aim to not comply with the agreement. And while this is an extremely low probability, it's a non-zero probability that diversion can take place. So it is a challenging situation for the IAEA with its interaction with countries in which, I accept everything you give me, I want to believe everything, but I cannot trust any of it unless I independently verify it myself. So it's a kind of a love-hate relationship. So nuclear material verification is the basic method used by the IAEA to verify that these agreements are being complied with. And so it relies primarily on actual accounting for all the nuclear material, supplementing these verification activities with containment surveillance practices to provide continuity of knowledge in between inspections and in between the measurements. So here's a few examples of some measurement systems. The upper left is a portable load cell device for hooking onto cranes so that if items are being weighed, the agency can get a weight value using their own instrument. The bottom right is another piece of a portable instrument, a non-destructive assay system for collecting gamma ray spectra to try to verify what isotopes are present and what is the concentration of those isotopes. Sometimes they will use process information to get information. Here's a picture showing UF6 cylinders sitting on process scales. Other times the agency will collect samples in the field to send them off to laboratories where there can be mass spectrometric analysis performed, chemical analysis, or other titration to determine elemental analysis. The challenge here is for the IAEA to make sure those samples that they collect in the field are representative of the content of the atoms are being sampled, and that they maintain a chain of custody of that sample from the time they collect it till it gets back to their analytical facilities. A couple of pictures showing fuel fabrication at a research reactor. You can see IAEA inspectors going there themselves to independently look to verify the identification of individual items, serial numbers, item numbers, to make sure inventory lists that are provided by the facility are, what did we say earlier, both correct and complete, that the numbers on the information provided to the agency match what is actually present, and that numbers for every item are provided. Secondly, the picture on the right, you can see this looks like a NDA measurement being taken place on the fresh fuel to make sure that the material in these containers are as declared and comply with the information provided by the facility. Containment surveillance measures are implemented to prevent the number of measurements that have to be performed. This shows a picture on the left of applying a seal to an item. The picture on the right shows the installation of cameras. Without containment surveillance, every time you come to the site to verify those inventory listings, you would have to remeasure every item to verify its contents. However, if those items do not move or change between inspections, with something like a camera system, if you can view the tape and have assurance that either none of the items moved and that no one accessed those items, you can avoid having to do remeasurement as long as the integrity of your systems can be verified. So let's talk a little bit about an example using a fuel fabrication facility. The feed material for a fuel fabrication facility is uranium hexafluoride, UF6. This is what's contained in large industrial steel cylinders. The output, the primary output of a fuel fabrication facility, is the fuel assemblies, which then go to the light water reactors. inside the facility, there may be a number of different processing steps that take place as you convert the UF6 to UO2. This UO2 is compressed into pellets. The pellets are inserted into rods. These rods are then assembled together to form the fuel assemblies, which are then sent to the power reactors. Now, the actual steps that take place are much more complicated than that, and this shows, again, another example. On the surface, again, you see the UF6 cylinders that are the feed to the plant. You see the assemblies that come out. However, we know that every process generates waste and scrap, so another important output stream that we are interested in from a safeguards viewpoint are the measured discards. Now, within the plant, there are many processing steps that take place and storage steps. The UF6 is stored in these cylinders until it's emptied. There's a process to convert the UF6 to transfer it from the cylinders into the process. The conversion processes to convert it into UO2, which is basically a powder form. You prepare the powder and you blend it. There are a number of storage steps that may take place within the process for UO2 and other intermediate materials. Mentioned earlier, the pellets are pressed, sintered, which is basically heating, grinded to get it in the right shape and form, basically some purification processes, loading in the fuel and the assembly. So you've got storage areas for pellets, for rods, for bundles. Ultimately, these bundles are what are shipped to the power reactors. Every one of those handling activities will have some rejects, will have some scraps. All of this material represents money, so there's certainly an intent to recover as much as possible. So you'll see scrap recovery operations to make sure the process is running right. The facilities will be doing sampling at the various steps across the process, so they will likely have some on-site analytical capabilities. These too will generate waste. So at the plant site, you'll have some solid waste, you'll have liquid waste, and you'll have gas waste as well. So there's a variety of streams that have to be addressed. So from a safeguards perspective then, when you come to inspect this facility, the facility will need to declare all the material in all of its different forms in all of these different storage and process areas across the plant site. And the goal of the agency is to be able to independently verify those declarations. So one of the ways they do this is dividing the plant up into material balance areas and identifying key measurement points where either the material crosses the boundary of these material balance areas or is in a form where it can be inventoried within that material balance area on a specified frequency. Now, this actual setup is something that is discussed and negotiated between the country and the IAEA on the actual format. The facilities, for their own domestic purposes, will generally have a much more detailed breakdown structure to meet their national requirements. The agency, on the other hand, will roll this up into something that minimizes the amount of activities by the IAEA, that minimizes the amount of intrusiveness within the plant operations, but also allows them to independently verify the entire declaration. So what you may see at a typical fuel fabrication is multiple material balance areas or sub-MBAs, and this shows 4. There may be one for UF6 cylinder storage, one for the storage of the final fuel assemblies after they've been put together, and then multiple MBAs for some of these processing steps. What's kind of beyond the scope of this course is how the agency looks at activity. They generally define materials as either individual, indiscrete items, such as cylinders of UF6, or fuel assemblies where the nuclear material does not change form, concentration, or quantity inside these containers. They're basically very straightforward to verify. The other category is a bulk facility where the material is changing forms. It's more of a fluid nature, and it's more difficult to verify. So in this particular arrangement, you see two item MBAs and two bulk MBAs. The circles with the letters A, B, C, D, E, F, G represent areas that material can be stored within these MBAs and then can be inventoried when it comes time for the IAEA to verify the declaration. The green diamonds represent other strategic points where material measurements can be made and then containment surveillance applied so that materials do not have to be remeasured. And then in the circles, the 1, 2, 3 are the flow key measurement points where material actually flows into and out of the plant that provide the declarations to the agency and areas where the agency has to measure the material. What are some typical measurements that the IAEA may provide at a fuel fabrication plant? Earlier we listed all the different, not all, but many of the different forms and containers you might expect to see if you visit a fuel fab. The UF6 cylinders, UO2 powder, pellets, solid, liquid waste, the fuel pins, and the assemblies in storage and processing areas. So for each of these, the agency has a measurement technique which may involve actually collecting a sample from the item. It may be involved weighing the gross weight of the item and combining that with the tare weight, the empty weight, being able to calculate the net weight or the quantity of nuclear material in the item, and then doing either analysis or independent measures to determine both the uranium content and the U-235 content. From a safeguards perspective, we are interested in being able to detect diversion, undeclared production of significant quantities of nuclear material. For uranium, for U-235, for HEU, the goal quantity is 75 kilograms of U-235. If it's low enriched uranium, as it would be for a fuel fabrication plant, the gold quantity is 75 kilograms of U-235 contained in that material. We're not discussing a plutonium plant, but for reprocessing spent fuel, the gold quantity for plutonium is 8 kilograms. For solid waste, generally you are contained to measurements of U and U-235 using NDA techniques. For liquid waste, which may be stored in tanks or accumulation columns, sometimes you're looking at measuring the volume of liquid that is there, sampling that volume to determine the concentrations. For fuel assemblies, if you've got a good measurement on each of the fuel pins, all you have to do is count how many pins are present and do a confirmation measurement to verify that those pins actually contain material. Some of the other measurements that may be used to confirm these assumptions are portable NDA on the cylinders, just to verify that it is nuclear material of a low enrichment level. For these individual fuel pins, there may be a rod scanner there, which is basically a gamma or neutron measurement instrument, which will scan the entire length of the pin. The plants use these for quality control. The agency can use this to confirm that the pins do indeed contain material. Again, gamma spec can be used for a quick check of enrichment at any point through the process. And then the weight values are very important since they will provide, generally the best measurement capable for total quantity of materials. These are especially important for the transfer points, on-site, off-site, and between material balance areas. So by doing all these measurements, ultimately what the agency is striving is to come up with an independent calculation for MUF, which is material unaccounted for. The MUF equation is, at some point, you would have performed an initial inventory of the whole facility. Over the course of your material balance period, you would have received new shipments of material. Each of these would have had accountability information associated with it, so you add that to your inventory. If your plant is working correctly, you will have generated product that you're shipping from your site. So for each of these product shipments, you would have accountability values for uranium and 235. So these would be decreases in your book value. And then at the end of your material balance period, you do another complete inventory to see if everything is there. Depending on the attractiveness and the national requirements, these material balance periods may vary. Generally, I think they are pretty much all once a year that inventory has to take place. Now, would you ever expect your MUF to be zero? The answer is, if it's a processing facility, no. We said before there's various waste, discard. Some of the measurements can be very challenging. They may have large uncertainties. There will be some small losses, either dust or there will be holdup inside your process equipment. There are measurement equipment may not be operating completely correctly all the time, or even if it is, every measurement has uncertainty associated with it. So there will be a MUF value, and the sites and the national authorities obviously will strive to keep this MUF, or sometimes is referred to as an inventory difference, as low as possible. When the agency does their independent evaluation of MUF, they will compare that MUF back to those significant gold quantities that we mentioned earlier. So stepping back now, back to the national system as opposed to this facility example, there are two very important documents that the agency uses for the basis of safeguards. These are all written out in information circulars. The first one, Information Circular 153, came out in 1972. Is that right, Ben? You had this in your class, the one you just had. I think it was 1972, which provides the format for what these comprehensive safeguards agreements have to obtain. If you don't have a copy, let me encourage you to go back to the IAEA website at iaea.org and just do a search for InfoCirc 153 to print this out. It defines all the obligations and requirements for the agency and IAEA related to establishing a state system of accounting for and controlling nuclear materials. It is the basis for which a country gives its specific declarations on nuclear materials and nuclear facilities. It provides a requirement for providing design information about those facilities. It defines the agency's rights to be able to verify that information, and it provides these terms in terms of timeliness goals, significant quantities, detection quantities, etc. So it is focused on the agency being able to reach this independent conclusion that no material that has been declared to the agency has been diverted. This was one of the primary tools that the agency used in designing its safeguards approach for many years until the discovery in the early 1990s, nearly 20 years later, that one member state, Iraq, had been conducting undeclared activities within their country. Although they were a member of the IAEA, they were a signatory to the Nuclear Non-Proliferation Treaty, they had complied with providing declarations on material which the agency were able to, under the 153 agreement, verify that those declarations were correct. Where they were in non-compliance was they had undeclared facilities with undeclared material, and the agency did not have specific authority to go looking for it. Within 153, there is a provision that the agency can hold a special inspection to resolve a question, but this was seldomly used, in which I think it had only been used 2 times since 1972. So this led to an activity within the agency in the mid-1990s to strengthen the IAEA safeguard system, to provide capabilities, to provide assurances that there were no undeclared materials or activities taking place. This agreement came out in 1997, referred to as the Additional Protocol. It is INFICIRC 540, and again, it's on the IAEA website. It is additional because this is a protocol that is additional to the Comprehensive Safeguards Agreement as defined by INFICIRC 153. So what this does, let me back up. While 153 provides information on all nuclear materials and all nuclear facilities, 540 is focused on nuclear-related activities not involving nuclear material, because those would have been under 5.3. So this would say include activities such as a country's 10-year plan as far as, are they planning to either go nuclear, are they planning to add more power reactors, are they planning to add a different type of power reactor, are they going to undertake an enrichment program, are they going to start a reprocessing program. It gives the agency a heads up as to what is coming down the road in terms of the national plans. It also lets them know if they are doing research and development on either new types of fuel assemblies or all aspects of the nuclear fuel cycle, such that if the IAEA gets information about an enrichment program, they would prefer to hear it directly from the country first, as opposed to trying to check out information from other sources. One of the strengths of the Additional Protocol, INFICIRC 540, is that it provides the agency complementary access to relevant locations to resolve questions or, again, verify that information. This is different from inspections of nuclear material where it has this quantitative aspect to it. These complementary access visits basically are there to look that indeed there is no nuclear material present and that the level of activity is consistent with the declaration. So therefore it is more of this qualitative verification. 153, you're making specific measurements to get a quantitative verification. 540 is qualitative. So this enabled the agency to, again, improve their capability to draw a conclusion regarding the absence of nuclear materials other than those declared under 153. I hope that is clear. If not, I think at the end you'll be having contact information. Feel free to contact me or the other instructors in this course. So in terms of a kind of a simple diagram, the state will make declarations to the agency about its nuclear material and activities under INFICIRC 153, information about its activities under the additional protocol if it's in effect within the country. Then the agency, IAEA, has to independently verify this information from the two aspects, that the information that is provided is complete and that, is correct and that it is then complete. Once a state has both a comprehensive safeguards agreement in force and an additional protocol signed and in force, of which the IAEA has been able to draw what they call the broader conclusion that all declarations are correct and complete, that country can enter into what is referred to as integrated safeguards. So once there is a conclusion, there's no diversion of declared material, and there is an absence of undeclared activities, then inspection activities can be optimized within that country to somewhat reduce some of the inspection frequency and the number of activities that take place, because there is this now assurance of no undeclared activities. So it basically becomes the optimum combination of all available measures within the agency. We've talked earlier about inspection activities that inspectors do on the ground while they're there. How many inspections took place last year? 2,000 inspections, 8,000 inspection days. And so there's quite a bit of time in the field where they gather as much data, quantitative data from these as they can. We've talked about the CA activities, that's complementary access visits. And what they try to do is somewhere on the order of about 4 of these for each country with an AP in force. There are other tools that take place at the agency's headquarters to supplement these first 2 areas. One, satellite imagery. They've got a department there set up using open source imagery from Google Earth and the other satellite companies where you can actually purchase info. They use this to either look at changes in the facility's footprint or to verify declarations that a country gives regarding the facilities present at a declared site. They also have another extensive information analysis and evaluations group that does searches on open source literature, on papers, presentations, journals, looking for these activities that they can then compare that with the both the declared nuclear and the non-nuclear present activities. The nuclear fuel cycle related, not involving nuclear. University studies, governmental studies, other activities. So using all of these together is what they use to achieve this broader conclusion. Once achieved, they can move from a more prescriptive planned number of inspections to reach their timeliness goals for material to a more of a what is referred to as a short notice random inspection. They don't have to go as frequently if they are getting all the information that they need. And this can really, again, lead to less inspections. Now, on one hand, you may ask, well, why do we want less inspections? I mean, don't we want more inspections? This comes back to the fact that the agency has a very limited number of staff due partly to a very limited budget. I didn't show the slide here, but the IAEA safeguards budget is on the order of about 120 million euros per year, which relates to about $150, $160 million a year based on the 2011 December exchange rate. And so it's not a very large budget. And so there's a question of how much effort should the agency expend in a country that has been very open, transparent, long history of compliance, and very supportive of providing information to the agency, versus areas that have been less transparent, less cooperative, pose a higher risk or concern regarding breakout. So if the agency can get all the information it needs from a fully cooperative state, then it should be able to spend less time in the field to reach the same types of conclusions. So that is one of the important benefits of moving towards this integrated safeguards. The others is just to increase their budget 100-fold, and then the same number of inspections could be done elsewhere. But we are all limited by budgetary constraints. So, to kind of summarize, the IAEA system is, again, it's a system whose objective is to assure compliance of the country of all of its non-proliferation commitments. The basis for the system are the declarations that these countries voluntarily provide to the IAEA. The IAEA does not have the authority to force a country to declare. If a country does not declare and the agency, the Secretariat cannot reach its conclusions, the way the process goes forward is they will report that to the Board of Governors that we discussed earlier, that they were not able to reach a conclusion. If the Board of Governors so desires, they can then raise the issue to the General Conference. At the General Conference, all the members can then decide whether to raise it higher up into the UN structure. If it is severe enough and significant enough, as we have seen in the last couple of decades, the UN may issue a special security resolution calling upon countries to comply with certain needs. So it is a system based on states' declarations, and in a simplified way, the agency is an audit system. They go to look for what? The correctness and the completeness of those voluntary declarations. So in summary, no safeguards system, no matter how extensive or measures, can provide absolute assurance that there's been no diversion of declared material or that there are no undeclared activities in a state. And this has been a really tough issue that the agency has addressed in a couple of years. If a country is under IAEA safeguards, the international community would like the IAEA to be able to say with 100% confidence there are no undeclared activities going on in this country. But to do that, they would have to have inspectors everywhere all the time looking at everything. And no country either A, wants that much involvement, or B, could we all afford that much involvement. So the agency looks to provide increased assurances through this high level of cooperation between the state authority, the IAEA, and then the facility operators. So with that, that concludes this presentation.